little discussion here. Okay, so what I want to do, I want to go to MATLAB assignments, and I want to click here to get MATLAB assignment 3. Okay, and there it is. There it is. And in the first problem here, okay, it says, suppose that we toss a fair coin. The probability of getting ahead, of course, is 50%. But suppose we toss, well, yeah, at any point in time, we look at the outcome of the previous 2 tosses, and there are 4 possibilities. Okay, so one moment here. So you see here, these are the possibilities. If you were to toss a coin twice, you could have a head followed by a head, an HH. You could have a head followed by a tail, an HT. You could have a tail followed by a head, TH, or you could have 2 tails, a TT. Okay, and we can think of these as states. Okay, state S1 is HH, state S2 is HT, and so forth. Now, what we want to do is we would consider the probability of going from one state to another in one toss. Okay. And in part A, they want you to find the stochastic matrix for the problem. The stochastic matrix for the problem. Okay, so let me give you a little guidance on how you would want to set this up. Okay. Are there any questions so far, though? Are there any questions so far with these 4 states? Okay, let me go to the whiteboard. And one moment here, I'm going to maybe use my little stylus here. Let me plug it in. Okay. So for MATLAB assignment number 3, okay, and we have, let's see, what are the 4 states? HH, then what's next? Tell me what's next. Good, that's right, Eleni. HT. Okay, next. Good. TH and TT. Okay. Now, each of these states represents 2 consecutive tosses of a coin. Okay. And we want to create a stochastic matrix. Remember the migration matrix? Well, we want to create a stochastic matrix that essentially is like migrating from one state to another state. So it's going to be a 4x4 matrix. 4x4 matrix. Okay, so you can think of this as the HH as first toss is ahead, second toss is ahead. And then here, well, you wouldn't have a first and second toss, you would have a second toss and a third toss. Okay, that would be how you would interpret that. All right. So let me ask you, how many entries are there in this matrix, in this 4x4 matrix? That's right, 16. 16 entries, right? 16 entries. Okay, let's look at the entry here. Is it possible to go from a state HH to a state HH? Is that possible? With some probability. Is that possible? Okay, the answer is yes. Why? Why is the answer yes? Why is this possible? What tells you it's possible? What key thing tells you it's possible? That's right. That's right. Good, Benjamin. The second result matches. So this, on the second toss, that matches the second toss. See, you got, so the second tosses have to match. Okay, so what probability are we going to put in that box there, or for that entry? Good, Haley. 0.5. There's a 50% chance. So basically, well, why is there a 50% chance? Haley, why is there? What's that dependent on? Is that dependent on the first, second, or third toss? This 0.5. That's right. And Haley, you're right. There's an equal chance on the third toss. There's an equal chance for heads or tails. So what I'd like you to do is I'd like you to talk among yourselves and figure out the remaining 15 entries, okay, for this matrix. Okay. All right, let me stop the recording there. Well, yeah. Well, I might mention one more thing. No, I'm going to stop there and let you think a little bit. Okay.